care of this as well. So here is the thing. Now, when we don't know a population standard deviation, we have to use the sample standard deviation, which means we have to go to our sample standard deviation thing. And when we use the sample standard deviation, we always take into account the sample size, and we'll take a look at that in a second. But that is the only basic difference in this. So instead of using a z-score, we're going to use a t-score. T-score table is a whole lot nicer, and I'll make a copy of one so you can have it in your notebooks. I should have had it and I forgot to do it. Well, this way it's easier for you not to switch back to the book, but I'll look that up. A t-distribution works like a z-distribution. However, we call this a family of t-distributions. If you look at the bottom of page 310, there's like a family of curves here. And it changes as n changes. So as the amount that you have changed, so does this guy change. Let me see if I made the curve. There it is. Mine's a little off here. What happens is this: as your n changes, your curve gets it gets closer to a z-score curve. As it reaches 30, it's like almost having a z-score curve again. We call this degrees of freedom, and what a degree of freedom does is this: everybody has a freedom of choice except the last person. So if I lined up 20 kids, say there's 20 kids in here, and there's 20 desks in here, and I sent you all outside, right? And I pulled you in one at a time, and I said, pick a seat, pick a seat, pick a seat. Everybody picks a seat except that last person. That last person doesn't have any freedom of choice. It's whatever seat is left. So our degrees of freedom is always one less than your sample size. That poor last person doesn't get a choice. Okay? He has to sit or she has to sit in whatever seat is left. So we use degrees of freedom in here as well. We're going to spend a little time with this so that it makes a little bit more sense to you. All right. So your random variable is normally distributed, but your population standard deviation is unknown. This is key. All right. Your properties, and I put this on your note page, are very similar to your z-score, except you're still going to have the mean, the median, and the mode equal to 0. It's still going to have a nice little curve. It's just going to have different shapes right now until it gets closer to the 30. The total area under your curve is always 1. The tails in the distribution are a little thicker than those in the normal distribution because of the way it's moving. And the standard deviation varies with your sample size. And that makes sense to us because we can't depend on your population. We have to depend on your sample. The t-distribution is a family of curves which is determined by your degrees of freedom. The degrees of freedoms are the number of free choices left after a sample statistic is calculated. So in other words, we just take n, how many in your sample, minus 1. This turns out to be what your degrees of freedom is. That's all it means. Take your sample size, minus 1. I'll give you these formulas as well, and I'm going to show you after we get through some of these, I'll show you the calculator step as well. Okay, now, we use a completely separate table for this. If you look at page 311, they give you an excerpt of this table. So first I just want you to look at the excerpt, and then I'll look in the back of the book for you. Good with this? So you need to open your book, 310. We're on page 311. So it says, find the critical value. You know you had a ZC, and how you found your ZC inverse norm, remember? We're going to do this with T. With T, we're going to use your table. So we're looking for a critical value for a 95% confidence interval when the sample size is 15. Because n equals 15, the degrees of freedom are going to be n minus 1. This is an easy table to follow. I've got a 95% confidence interval. So I'm looking at table 5. Here's a little excerpt. Look at the words on the top. See where it says level of confidence? Isn't that my level of confidence, 0.95? Just follow it till you see 0.95. See it highlighted? Now come down until you find the degrees of freedom of 14. See the TC? That's how easy this table is. So TC is 1 point, what does it say? 2.145. Thank you. There's two other rows up there that we're going to use later on those columns. One tail, two tail. We're going to use those when we do hypothesis testing. But right now, this is easy to match up. This is the level of confidence, 0.95. I look for 0.95 on top. I find my degrees of freedom. I find my TC. Do you notice all your TCs are positive? Usually when we did the inverse norm, didn't we come out with a negative and we had to make it positive? This one, they're all positive. In the back of your book, it's in a table in the back of your book. If you go to page A18, and I will make you a copy of this table, it's a full table. If you kind of like follow down the side for a minute, if you look down at the 30, when n is 30, are you with me on n is 30? Okay, and then you kind of go down, it goes down to 31, it goes down to 40, and then look what happens. It goes up 5, and it goes up again, and then how, see the bottom house goes up a lot? There's not a lot of differences in those numbers, so they kind of jump those numbers. So eventually, if you go down to infinity at the bottom, aren't those your z-score numbers? As we reach infinity, those are your z-score numbers. Okay, and they jump a lot. They really don't, that doesn't really make sense because it doesn't fit inside your chart. So that number, if you look up top, they're going down and down and down. Okay, so the rest of this is going to pretty much work the same. Table is even easier than before. You don't have to do the inverse norm on this. There is on your calculator an inverse T, but the table is so simple, we usually use the table. If you go to your calculator inverse T, you would do the same thing. 1 minus 0.95, oops, divided by 2, takes me longer to put anything in here, divided by 2. Degrees of freedom, you would have to enter your degrees of freedom at 14, and you would paste. For those of you that like the calculator, this works out real well. That line, there it is. And it comes out a negative, which you would have to make it to a positive. But your table is nice for this. You don't have to subtract anything. You don't have to force the negatives to become positive. If you want to do it on your calculator, it follows the way your z-score works. It just has a t next to it. So for those of you that don't like the tables, the calculators work fine. But this table is so simple to read. I use the table instead of the calculator. It's just so simple. All right, so you guys find me, write yourself one. Ladies in the back there. Yeah. So Sarah, tell me how I would do this. Find the critical value TC for a 90% confidence when your sample size is 22.
You go find your level of confidence.
Okay, find your level of confidence, 0.90, and then what do I look up on the left side? No, 21. Notice that column says degrees of freedom. It doesn't say sample size, right? It doesn't say sample size. It says DF. So 22 minus 1 is 21. So 21 and 0.90. What is my TC? Flip to the back of the book. A18. A18. It's in your book. A18. This is why I'll make you one for your notebook. I'm sorry, what was the first one? Did everybody get that?
Is there a way not to use those charts?
I just showed you on the calculator, but you guys were paying attention. Yeah.
No, I know what you did. I was just asking. I didn't know what you did.
It's the same way as the inverse norm goes, but it's an inverse T. So you would have to say 1 minus 0.90. You would have to use your degrees of freedom 21. You would get a negative, which you would make a positive. So I'm saying the table is so much easier because it's clear. Level of confidence, DF. Not on that one? No. I don't use a calculator for that one either.
You won't ever give us one that's not like, okay, so.
No. We would only give you those, and well, I take that back. If we do, you're just gonna round to the, I think it's the one before it. I forget what it is, the one before it. I think it's the one before it you would take. Like if I gave you a 55 and there's a 50 and a 60, you just take the 50. All right, so now, how else does this affect us? Not a whole heck of a lot. Instead of verifying that your population standard deviation is known, we verify that it is not known. We still need to be told that our sample size is either greater than or equal to 30 or that our population is normally distributed. We still need to identify these pieces. The extra thing is my degrees of freedom. I have to look it up on my table, find TC from your table, table 5. Find your margin of error. Notice this is a little bit different. What was it before? ZC, population over square root of n. What changed? Instead of a ZC, it's a TC. And instead of a population, it's just a sample standard deviation. Really, it's kind of like invisible. This is a ZC now is my TC. My population is now my sample. The rest stays the same. We build the interval the same exact way. X plus or minus my margin of error. We'll walk through this, and then I'll walk through a calculator step as well. That's how easy this is. So some of you might need a little bit of reinforcement from 6.1. This will be a good reinforcement. 6.1 basically works the same concept, just a little bit cosmetics. It's different. So let's try exercise 2. You randomly select 16 restaurants. This is important. What variable does 16 restaurants represent? So that's the N, right? Good. Okay. And you measure the temperature of the coffee sold at each. The sample mean, I still get an X bar, is 162.0 degrees Fahrenheit with a sample standard deviation. This one's different. It says sample instead of population. So we write S because we know that this is my population, this is my sample. So in terms of standard deviation, this is my sigma, this is my S for sample. My sample standard deviation is 10 degrees Fahrenheit. We want to find, with a level of confidence of 0.95, the interval for the mean temperature. Now look what they told us. Assume the temperatures are approximately normally distributed. They have to tell us that. Why? Why did they have to say that in this problem? Because n is less than 30, right? If it's greater than or equal to 30, they don't have to tell us because then our sample models a normal curve. Our population did. But because we're less than 30, they have to tell us this is normally distributed. If they don't, we can't do this problem. Granted, the T has a series of curves, but we're okay with that. All we have to do is know that it just falls like a regular normal thing. Are we using this? We don't even need to do this part. So we go to our problem and we say x plus or minus 8. We need to build a confidence interval. So we say, oh, we need a margin of error. We know the sample mean. We need a margin of error. Our margin of error formula says, give me a TC. So to do a TC, the only other thing I need is the degrees of freedom. So if my sample size is n, what is my degrees of freedom? 16? 15. Remember that last person doesn't get that degree of freedom. There's one person that doesn't get a choice. So take that away. Now, go to your table, look up 15 and your degrees of freedom, go across the top till you see 0.95 and just pull out that number. It's going to be positive. Your table will say positive. Just pull out that number. If you found it? 2.131. Thank you. This is how simple this is. So I find my margin of error. It's already positive for me. I put in my sample standard deviation, 10, divided by the square root of 16. All I got to do is throw that in my calculator. How many decimal places should this contain? My margin of error. How many does my mean have? 1. So break this down to 1 decimal place. Even though it's 0 in the mean, they want you to include that decimal. So all I have to do now is take my mean, plus or minus my 5.3. And I do it the same exact way I did before. 156.7, comma, 167.3. Or I can do it as an inequality. Okay? And my statement stays the same. I can be 95% confident that my population mean for coffee sold, well, the temperature will be between 156.7 and 167.3 at this restaurant, wherever it's being sold. Okay? The rest stays exactly the same. This is changing. This is changing. Now, for your calculator step, those of you that like the calculator, we're still in test. We're looking for an interval. Let me pull up all my intervals. Which interval do you think it is? T. T interval. Number 8, right? I did a Z, now I'm a T. Just come to T interval. It prompts you the same way. My X bar, 162. My sample standard deviation is what? 10. I don't need the point zeros on these. My N, 16. My thank you. And they calculate. Now, again, I don't know my margin of error. So the same way we did with your Z-score. Take your mean and subtract it. 5.3. There's my margin of error. Yeah, I can. It's very smart. But I gotta clear the ink from my calculator first. So are we okay with that? Not a lot of change. Concept is the same. Your major difference is your population standard deviation is not known, only your sample standard deviation. Guys, you need to put away your phones. The deal is, I don't want to see a phone out while I'm teaching. If you're working on your own, I don't care if your phones are out. But if they're out when I'm teaching, that pisses me off. So we're not going to do that. Okay, I'm pretty lenient with you guys. Don't you think?
I think.
So I don't want to see your phones out. Okay, now, I want you to take a minute, and I want you to redo that information. We had a mean, had a standard deviation of 10.0. Okay. We had an N of 16. I want you to redo a 90% and a 99. So these three rows, one, two, three here, guys, you do the 90%. These three rows, you do the 95. 99. Thank you. So, see if you can do it both ways. Try it with your calculator as well. Your margin of error formula is just about the same, but it's just a TC. Ladies,
She's directing you through the margin of error.
and we're going to see if that same rule applies that applies to your Z-scores. If the confidence interval changes, your confidence level changes your interval. Some of you got this backwards. Okay? Are any of you guys doing this with margin of error? Are you using your margin of error formula, or you use your formula?
Yeah.
One of you ladies want to come up and do the 99 for me?
It's like write it.
Yeah. You want to do it together, since you do everything else together? And we hear all about it?
No, I just don't want to. I'm really sorry.
Is there anybody from this group that would like to do it? If you did the margin of error formula? Okay, you want to do it for us, Angeles?
No, she wants to do it. Let her do it. It's hard to stand up there, you know? You just don't know how you do it.
The level of confidence is like 10.
The level of confidence is 10. So therefore, that will help you boost your confidence. So I have no problem talking. That's what happened, I got off track.
I was like,
I have never used to talk French people. I will say though, when I was working as an analyst, if I went to a meeting and I disagreed, I spoke my piece. I did. But I speak easier now in front of people. Does anybody want to put this up?
We're just doing the margin of error.
Well, we're doing the whole thing. All right, Angelique, so tell me what you have. Let's do this. What's your degrees of freedom? Same thing, 15. What's your TC for this guy? 2.947. Everybody got 2.947? Okay. Times your standard deviation over your square root of n. So what'd you get for your margin of error, Angelique?
7.4.
7.4, because you rounded. Good. So x bar, this works the same. And again, you're going to get 154.6 to 169.4. I'm going to put this on a number line. I'm going to put my mean in the middle. This way we can see what happens here. So I'm going to put 154.6 and equal distance this way, 169.4. Okay. Anybody come up with a TC for this guy? This group? Naya?
oh, no. I was just stretching.
Who's got the TC for me? Tori? 1 point, say that again?
7.53.
Okay, 1.753 times my standard deviation divided by the square root of n. What's your margin of error? Okay. we come out with 157.6 to 166.4. Let's put this here too. Notice 157 is here and 166 is here. So let's make a conclusion here. As my level of confidence increased, what happened to my confidence interval? That increases. It widens. Good. It widens. Good. Okay? So as I become more confident, I need a little bit more wiggle room. Agree?
Like the opposite of what you're saying.
You think that sounds opposite?
Yeah, I feel like if I get more confident, it's gonna be more precise. Because like I'm confident that it's that number.
But in a margin of error gives you, think of it this way, a wiggle room. So if I need to be more confident, give me a little bit more space to work with. Think of it that way. Give me a little bit bigger wiggle room. Yeah. Okay? So tomorrow